I hope everyone has a great session today. And I'm going to pass the mic over to Chris and say hello.
Okay, good morning, everybody. We still have snow in Ottawa, but it is melting very quickly. So hopefully you've got some good weather and a feeling of spring wherever you are. So this morning we're going to be talking about supporting teachers and enhancing math teaching and learning. And it's nice to see so many participants. And I know that some of you are participating in groups. And so when we do have some moments where you're entering things into a specified chat pod, then I'll also make sure I give you a little bit of time to have some of that discussion. I also noticed that we have people from both elementary and secondary schools, and that just is helpful to me so that I make sure I include examples that pertain to both panels. So that was why I asked for that information. So some of what we're doing today is we're going to, first of all, set the stage with an overview of some guiding principles for school math, as well as then moving into, so what does effective teaching and learning actually look like? And of course, the implications for professional learning is why we're all here today, is to talk about how do we support teachers in enhancing math teaching and learning, and try to give you even some specific resources that I've found that people have worked with that have been quite useful. So hopefully that will be useful to you as well. As Ben mentioned, feel free to put in a question at any point. I might not address it immediately on the spot, but I will address it either when it's more closely tied to a particular point in the presentation, or at the end of the presentation. So please feel free to do that. So I'm leaning on, for these guiding principles for school mathematics, I'm going to lean on the 6 principles that are actually outlined in the National Council of Teachers of Mathematics document called Principles to Action. And this is a document that came out a little over a year ago, which I find kind of sums up and puts in very succinct kind of bullet points, almost, the kinds of things that research is really telling us about what is effective mathematics teaching and learning. And it's not, I'm not selling the document, but it's not a bad document to go to. It's the kind of thing where often we don't have time to read a full book, but it's the sort of thing where you could open to any particular page and there might be a chart or table that reminds one about productive teaching practices, or reminds us around what's good assessment. And so I find it a handy guide. Also, the other thing is there's an executive summary, which is neat, and also it's available in PDF for not too much money, so one could have it around, or one could use parts of it as a book study or professional learning within a staff meeting even. So they outline 6 principles. The first 2 are professionalism, and of course that's why we're all here today, is because of your commitment to professionalism. But it really is the idea that teachers are accountable, and being accountable means that we stay on top of our own professional learning, whether we're talking about principals as instructional leaders or whether we're talking about teachers. Another is access and equity. And Ontario is actually quite famous for its equitable practices. Quite often when I'm visiting other countries or at an international conference, Canada is often talked about as being not only a country with high achievement in mathematics on international assessments, but we're also a country where the gap between our low achievers and our high achievers is fairly small compared to other countries, which says quite a bit about our equity practices. In other words, the kinds of things that are occurring in our schools are the kinds of things that really help to sort of mitigate those factors, which might be socioeconomic factors. So a reminder then, just while we're talking about equity, that all students have the right to engage in rich mathematical activity, and all students need opportunities to develop their own strategies for solving problems. All students need time to investigate mathematical ideas. All students need time to develop conceptual understanding, and all students should feel valued as mathematical thinkers. And I kind of think this is really important because quite often we have this feeling that it's only those students in the enhanced class that actually should be engaging in rich mathematical activity, or that are valued as mathematical thinkers, or that can actually engage in problem solving and develop their own strategies. But it actually is important that all students do this. And I kind of feel as though it's an inequitable practice if we don't give all students that opportunity to do that. Sometimes we have teachers who feel as though some students might not have the tools to do that, or they might need more practice on the skills. But we also know that giving students a worksheet with another 50 questions of questions already they can't do is not necessarily the best way to move forward. And a lot of research actually shows that those students who benefit the most from the opportunities to develop their own strategies are actually the struggling learners, because all of a sudden the way that they think about mathematics is valued within that classroom. So I think that was something I just wanted to reiterate. Two other principles out of these six that I'm talking about are assessment. And there, of course, have been webinars around assessment. But what are some important aspects about assessment that we need to think about? That really assessment should be embedded in instruction. It should be seamless. It should be ongoing. It's about the way a teacher questions and listens and responds to student thinking. And also that we need a variety of strategies in mathematics, because there are a variety of mathematical actions that occur, and they cannot all be measured by the same type of assessment strategy. And I know in Ontario, we talk about conferencing and observations and products, or conversations and observations and products. And these things are really important because we do not always see students thinking in their written work. So another is tools and technology. And really, this is what I call mathematical thinking tools. So again, all students have the right to be using these kinds of materials. It's not just struggling learners. Quite often, people feel as though manipulatives are either for the low grades, we take them away in grade 5 and 6, or people think that they're only for the struggling learners, or teachers might say, well, you can use these for as long as you need to. But I have seen people in university math courses, graduate courses in mathematics, use mathematical thinking tools such as linking cubes, or dynamic geometry software. So when I say mathematical thinking tools, it could be anything. It could be manipulatives, as we usually see them. It could be as simple as graph paper. It could be a ruler. It could be a milk carton if I'm looking at a three-dimensional object. It's any object that we actually use to help us talk and think about mathematics. And the more we actually can connect the mathematics to the kinds of things that we see around us, the more these sorts of models are going to help us think mathematically. So I think it's really important in terms of mindset that we acknowledge the value of those. Most of you who might know me know that I travel around with a trunk full of these, so they certainly are part of my repertoire. And two others, and these two I'm going to focus on a little bit more, and that is curriculum. So we know that a sound math program has to have a sound curriculum that really recognizes research in terms of how students learn, which is embodied in things like learning progressions, and really recognizes the kinds of connections that one can make between mathematical ideas. And we talk about our curriculum. I know sometimes you hear from parents or we hear from the media about this new curriculum. And I want to remind us that this curriculum has been around from 2005, so it's 11 years old. And we're still working with it, and it still is useful. I know that the ministry is reviewing that curriculum, and I'm sure that they'll be taking into account any of the research that's been done in the past 10 years to look at it. But I'll talk a little bit more about that. And of course, teaching and learning. That effective teaching really engages students in meaningful learning and promotes their ability to make sense of mathematical ideas and to reason mathematically. So another key idea, which I want to talk about in more detail. So I'm actually going to soon be going through effective practices. So first of all, just to dwell a little bit more on what we know about the Ontario curriculum. We know that when the curriculum is designed, that it actually, a review process, research reports are written, and consultations, an analysis of our curriculum with the curriculum of other jurisdictions, particularly the high-performing countries, is looked at. And so we know that it's fairly thorough and fairly solid ground. And I generally encourage teachers or the teacher candidates that I work with that really the curriculum should be the starting point. It's not the textbook that should be the starting point for the lesson. The textbook could be a great resource, but it really is the curriculum that we're thinking about doing. And if we think about the curriculum, it really helps to describe to us the actions that should be occurring in a mathematics class. What I've done is I've pulled out some of the verbs that I actually see in the curriculum. And the interesting thing about these verbs is they always follow the two words that say students will. Students will compare, students will describe, students will verify, students will graph, students will distinguish. And I try to emphasize that with teachers, that it doesn't say that teachers will describe or demonstrate or represent. It says that students will do these things. So if I walk into a mathematics classroom, these are the kinds of things I should see students doing. And as instructional leaders, I know that you're often walking in and out of mathematics classrooms. And again, if I'm working with a teacher candidate or working at co-teaching, co-planning, I go back to the curriculum and I say, well, what are the verbs in this expectation or these expectations that I'm addressing? Because those are the kinds of things I should see students doing. So I mentioned that I would do a little more detail around curriculum, which I just did, as well as teaching practices. So again, I'm drawing on the principles to action to be able to frame effective teaching practices and talk about those in just a little bit more detail. So many of these actually sound like sort of apple pie motherhood statements because there are many of the kinds of things that we already know, but it's nice that they're kind of succinctly placed here. So one of these teaching practices is establishing mathematics goals to focus the learning. And I know a lot of work has been done around the province around establishing learning goals, establishing success criteria with one's class. And it really is thinking about these goals for mathematics. So thinking about them in terms of the big ideas for mathematics. One thing I think I would caution against is trying to make sure that when we establish these goals, we keep the openness of the exploration of mathematical ideas so that we don't narrow these goals too finely. Otherwise, we don't allow that space for students to do things like develop their own strategies, etc. Another math practice is procedural fluency and conceptual understanding, and talking about the way those two things are intertwined. And this relates to both elementary and secondary mathematics. That let me first give an example from elementary mathematics. So it's as students are developing number operations, they might first be working with concrete materials to understand such things as like a tens frame and understanding how to compose and decompose numbers. And then they might be moving to developing some particular operations for addition. So for instance, they might be working on 5 plus 7. So they might be relying on the idea that they know 5 plus 5 would be 10, and then they're maybe adding on 2 more. That's what's called phase 2, is when the students are actually developing their own strategies. Phase 1 would be when they're working with the materials. And phase 3 then is that over time they develop a fluency. So they develop this sort of basic fact fluency so that they can quickly come to what 5 plus 7 is. And quite often in traditional mathematics teaching, actually phase 2 tended to be skipped. We sort of moved to from letting kids work with concrete materials to then jumping to memorizing basic facts. And there actually was nothing in between for them to hang their hat on. So in other words, if they happen to forget that basic fact, then what happens is they really have nothing to lean on to reconstruct their understanding. So it's thinking about the way those things go hand in hand. And if I think about a secondary example, it's such things as giving students particular formulas without taking the time to develop them and have them play with the ideas and have them experiment and have them try to come up with particular formula. So for instance, sometimes in grade 9, teachers might give them y equals mx plus b and teach them m is this, b is that, without developing some of these ideas within context, so that they can maybe look at the ordering a pizza and thinking about what slope or y-intercept might represent, or cell phone bills, to develop that conceptual understanding. So if they forget what it is, they can lean back on that. Another one is implementing tasks that promote reasoning and problem solving. There's been a lot of discussion about rich tasks, and I'll talk a little bit about some of the criteria for rich tasks. This doesn't necessarily mean that every day we have to be engaging in rich tasks, but it does mean that there's a lot of student learning that occurs through rich tasks. And some of the characteristics of a rich task is that they really encourage high quality student interaction, and that they would have multiple entry points. So multiple entry points means that the question is open enough so students might begin to approach it in a variety of ways. It could be that they might be working with linking cubes, they might be drawing a diagram, they might approach it by drawing a graph. But there are many ways that they can sort of at least begin to explore the problem. Working together then, those multiple entry points, and sharing the kinds of things that they're doing would allow them to then develop and further explore that problem. A lot of researchers have been talking about tasks that have what's called high cognitive demand. So the kinds of tasks that really are engaging, don't have an immediate answer, and allow for different approaches and different ways to solve that. They allow for discussion. They allow for time to be able to explore it. They allow for us kind of taking a break and thinking about it and then coming back to it. So I'm going to give you a minute. And I'm not going to give you enough time to actually solve this, but what you might want to do is at least look at this problem. I borrowed this from a case study I did in a grade 8 classroom, but it works for many different grades. I've used it in grade 9, grade 7, grade 6. And what I might encourage you to do is, this is one where mathematical thinking tools really help. So if you've got some, you probably might not have manipulatives on your desk right now, but maybe you've got some dimes and quarters and nickels in your pocket, and you might want to just start exploring it. So I'm going to give you about 2 or 3 minutes at least to take a moment and kind of get started on how you might approach it. It's also a problem that will remain within that PowerPoint, so that when you download it, you might want to use it with your staff or students.
This is just an audio check for Natalie. Natalie, hopefully you're able to hear me.
So this is the hard part about doing a webinar. I don't know whether people are engaged or checking their email in terms of working on this problem, but I think you've had a chance to at least look at it and think about it, and definitely not enough time to be able to solve it, but it certainly is something that you can go back to. In looking at this problem and looking at the student solutions, the reason I suggest this might be a good example of a rich task is because I saw students solve this in many different ways. Some students use symbols, some students use linking cubes, some students use colored little square tiles. Most students drew pictures of dragons. But the mathematical ideas that came out in this problem I thought were quite interesting, because some students used what I would call algebraic thinking, because they used a method of substitution. And some of you might have been doing something like that as you were working on the problem. So in some cases, the substitution was around moving tiles around. But other students use some proportional reasoning. So they happen to use friendly numbers and give values to the frogs and values to the fairy godmothers. Others used fractions. Some used percentages. So again, proportional reasoning, but thinking about things as percentages. And still others use unit rates. I remember one student who said he was thinking about it like Pokemon, and he was giving everybody a different strength, but he was recognizing that the strength of one depended on what he assigned to be the strength of the other. So it was the kind of question that actually pulled out a variety of mathematical thinking, also had that multiple entry points for students to be able to kind of move into it. And again, the goals that the teacher had set up, the learning goals for this class, was really open-ended. So she was not directing their thinking to think algebraically and use one particular method. She really wanted to be able to connect the different methods that the students used, as she later discussed and had particular students share, and she connected the ideas. So again, moving back to this mathematics teaching practices, another one is supporting productive struggle in learning mathematics. As educators, we often are so ready to jump in and help students because that's what it is we're doing. We're there to support students. But it's really important that we provide space for students to struggle a bit. We provide wait time. We provide them the opportunity to come up with their own ideas rather than jumping in and scaffolding too early. And that's something that I feel that we need to work on and we need to practice. So going back to what I saw as my qualities of rich tasks, I've added on here in blue because some of the researchers have noticed that when they've worked with teachers about developing or using tasks with a high cognitive demand, they notice that actually when they start to use those tasks, the researchers have noticed that quite often the teachers jump in a little too early or break the rich task into parts to make it easier for the students. So what they actually have done is taken the high cognitive demand of that task and reduce that task then to be low cognitive demand because of the degree of their scaffolding. So this is an important piece where teachers need to think about maintaining that high cognitive demand and thinking about allowing students to decide when they might need a hint. I know I've seen some teachers use hint cards. So if the student wants a hint, they might kind of go up and peek at a hint card. But really, it's important that students develop and build confidence. It takes time. If students are not used to this, you can't really jump right in and throw them in, and they're soon going to get really frustrated and get angry at the teacher for not helping them. But it takes a while to build that sort of release where students can actually work on their own. So another effective teaching practice is using and connecting mathematical representations. This goes along with the idea of the mathematical thinking tools as well, in that the more ways that we see a mathematical idea represented and our ability to connect those representations really helps to deepen the understanding of the math concepts and develop those as tools for problem solving. So here's an example of it's a pattern and it's a problem. It might be one that you might have seen before, where people are asked to generate the pattern for those linking cubes at the top. The bottom row, or sorry, the second row is another way of organizing those linking cubes. But the different kinds of patterns that are also represented there, or the different representations of that pattern, would include the graph, a table of values, an equation, and some word descriptions. So I like, for instance, the one on the bottom that says this figure continues to grow to the left, right, up, and down, adding 4 squares for each new stage. Now, this really represents the idea that at a variety of different grade levels, you could use this same particular problem where you would ask people to describe the pattern that's represented in that top row. And depending on the grade level, you might get people talking about this pattern in words. You might get people talking about it in terms of symbols at the secondary level. You would have them perhaps representing it using a T-chart or a table of values. And at some stages, they might be graphing it. So again, a problem that can be approached at a variety of different levels and could pertain to a variety of different grades, depending on the types of representations. But notice how this picture shows many representations, and we can sort of see how those connect together. Another math teaching practice is posing purposeful questions. Posing purposeful questions is really important as that's part of that embedded assessment. So in other words, asking the kinds of questions where I am trying to get at the student's thinking, not just asking the kinds of questions where I'm looking for a right answer, like, so 2 plus 3 is what? 5x plus 6x is what? What's the next step in this quadratic formula? No, we're really looking at the kinds of questions like, so why is this linear? Or what made you think of using unit rates? And the teacher is listening in such a way that they're trying to get a sense of that student's understanding so that then they can help to move that thinking forward. Just give you a little tiny portion of a transcript where teachers are asking questions, and this actually relates to the problem that you got to explore for a couple of minutes earlier. So the teacher, I've highlighted in blue, says, okay, so can you explain this to me? Or what made you think of unit rates? Or what did you find out when you did that? Or just one where there is a right answer, and how many fairy godmothers were there? Here she's paraphrasing in the next. So if you said you divided 4 frogs by 5 fairy godmothers, so kind of showing that she recognizes what they did, but also prompting them to move on. Or another one, okay, why does that make sense? Like, I love that question. I think we could write that on our hand as a teacher could write that on their hand, and that would come in handy anytime. Okay, why does that make sense? Another one I've seen in one of the other transcripts that I really liked was, okay, could you explain to Emily? And that's kind of a way of pulling in the other partner in this discussion. Perhaps the teacher recognized that somebody was a bit left out of that solution. So, working with teachers, and there are a couple of monographs out there from the ministry on asking good questions and what kinds of questions to ask. And those kinds of questions that get at student thinking to help the teacher think about where do I move next are really helpful. Another one is facilitating meaningful mathematical discourse. And this really means discourse among students so that we develop a shared understanding of mathematical ideas. It is not only the teacher who's the mathematical authority in the room, nor is it only the textbook. We all are mathematical human beings, and students can also be authorities for mathematical ideas. And so moving from this sort of setup where it's teacher-student to moving to something where we have this shared understanding through mathematical discussion and facilitating that mathematical discussion. So it's student to student, which is much more important and takes a while and takes time to build. And it requires that we work with students as well so that they can pose some meaningful questions to one another and respond to one another's thinking without always leaning on the teacher to see whether or not it's right. Another one is eliciting and using evidence of student thinking. So that sort of goes along with that, posing those questions, doesn't it? So that really is looking at the student thinking to think about where do I move next with this particular student, or it could be where do I move next in terms of the entire class. So it could be, I see many teachers are using, let's say, exit cards, and thinking about the kinds of questions that one might put on an exit card so that we're eliciting the student thinking, that it's not just a quick question that you might put on a quiz, but but maybe have them explain some piece of the lesson or some what they took away from doing a particular activity. And it helps that teacher think about moving forward. Or it's sitting down with a particular group as they're working on a problem and eliciting the kind of thinking, asking questions to this whole group and asking questions to them as individuals so that they get a sense as to what are the kinds of things that these students are thinking and where do I go next, whether it's to the whole class instruction or whether it's to this individual group, what question might I pose next? You know, it was interesting. The other night, I teach graduate course on Monday evening, and I was waiting for the prof before me to finish up, so I was outside the classroom. And as I looked in, I saw that her very last slide on her PowerPoint said exit card. And so there we are at a university setting, and here's a prof who is asking them to write an exit card so that she gets a sense of their understanding. I think so often people feel that all these things are happening in the elementary school and the secondary school, but not necessarily at university. So it was really nice to see that exit card strategy being used in a university setting. So I've talked a lot, and I want to hear from you in terms of, you know, many of the things we talked about. I suspect many of you probably already know. Those are the kinds of things that you have seen happening in classrooms, or they're the kinds of things that you'd like to see more of happening in classrooms. So I'm going to encourage you to type into the chat pod. What do you see as some of the challenges to making this all happen? And later we'll have the opportunity to talk about what are some of the things you've done to help make this happen. But right now, let's just look at what some of the challenges are. So take some time. If you're with a group, you might want to have a small discussion to decide what to type in. If you're on your own, then you might be ready to type in, and then we'll have those others who are groups type in a minute. Thanks. So I see lots of things coming up. I want you to keep on typing, but I'll start to talk about some of them as we go, because there's a lot happening. There's a lot of discussion about this mathematical knowledge, and teachers perhaps knowing memorized procedures, but don't necessarily have the conceptual understanding to facilitate some of this, and we're going to talk about that. And it's through no fault of their own, and I think it's really important that as we talk about this, it's not the teacher's fault. It's actually the way that they were taught. You feel sometimes like it's a bit of a vicious circle, isn't it? That people teach the way they were taught, and we're trying to disrupt this a bit. But as some of you mentioned, that this lack of deep understanding of math is somewhat of a challenge. Also, some of you have talked a bit about parents and some of their reaction to some of these. Some of you have talked about the use of manipulatives and using those in ways that make sense. And I'll just wait for a couple of other people to type in. If you've been with a group, you maybe are just getting your ideas on the table, so we'll give you a chance to type that in. And I see resistance to research, yeah. And over-reliance on technology. That's interesting, isn't it? Smart boards came out, and I don't know, it's kind of like the teacher space, not necessarily collaborative space. So I think that sort of set us back a bit. Thinking about a change in mathematics. Okay, so let me move on to some of the, you're all great. You all know what the challenges are out there, and that agrees with what some of the research says as well. So if we could get the PowerPoint back to the big screen. Thanks. So thank you for all of your comments. It's really good to know for me what you're seeing out there in the field and in your school. We know that teachers are really crucial in developing students' mathematics understanding, and that's sort of the key to all of this, which is why we're all here today, really. That they're challenged with developing students' conceptual and procedural understandings. They also are challenged with developing their own what is called in the research literature mathematics knowledge for teaching. So it's not the kind of mathematics that one necessarily gets from a whole pile of university math courses. It's actually understanding the math that they're teaching in very deep kinds of ways and being able to kind of make the connections between the mathematical ideas. Sometimes I find too, teachers might be receiving mixed messages about what math is important to know and to do. Sometimes people might think it's a narrow band of things that are easily assessed on a multiple choice assessment rather than the broad spectrum of curriculum expectations and some of those actions that we talked about before when I was talking about curriculum. So math knowledge for teaching, as I mentioned, is a body of research, and it's not only in Ontario. If I go to an international conference, then one of the topic study groups is always on this issue of math knowledge for teaching. As we ask teachers to work in ways that engage students in developing their own thinking, as we ask teachers to assess in different ways, as we ask teachers to draw on tasks and connect mathematical ideas, it challenges their math thinking. So that happens no matter where it is that we're talking about. But really, this math knowledge for teaching is understand mathematics in ways that help students develop their own math thinking. So knowing what question to ask next, knowing what representation would best match the math concept, recognizing the mathematics in the student's thinking, choosing appropriate tasks. And many of you actually mentioned those things when you were talking about what some of those challenges are. Many elementary people don't see themselves as math people. I think everybody's a math person, so let me get that on the table. So everyone is a math person. We're all born with mathematical ideas. I find sometimes we go to school and those get erased, and math is seen as something that's very foreign. I often use the example of a researcher named Paul Cobb who was working with a student who had just learned about the carry the one thing with adding numbers together and was doing 16 plus 9 and kept getting 100 and something. And he said to her, So if you're home and you have 16 cookies and 9 cookies, so how many would that be? And she said, well, that would be 25, but that's easy. That's math at home. That's not math at school. And so, this whole disconnect and not recognizing that people are actually math people and building on what it is they know. So we know sometimes that a teacher's understanding of mathematics might be more fragile rather than robust, and often it's because of the ways that they were taught. So this is a hard thing to tackle. And I'll just share some data. It is from 2007, but I suspect we'd see similar things today. This was only a study that was looking at grade 7 to 10 teachers, and this is about their teaching qualifications. Now, actually, intermediate teachers of grade 7 and 8 are not required to have any specialist certificates in teaching intermediate mathematics. But one of the dilemmas that this data actually presented to us was that those who are teaching grade 7 and 8 who were interested in enhancing their own math understanding and maybe taking the AQ in intermediate mathematics were not able to at that point in time because they needed a certain number of university math courses. And luckily that has changed. We know that there's an AQ for grade 7 and 8 teachers that does not require that. So I think thinking about having more opportunities for people to be able to engage in additional qualifications or other work to build on their understanding of the math that they teach. The other thing that we saw in this data was that again, we were only looking at grade 7 to 10 teachers, but that notice that those who were most comfortable with the content of the course tended to be the academic courses in grade 9 and 10, and those who were least comfortable with the content of the courses that they were teaching were around grade 7 and 8, or perhaps the teachers who were put in to teach the grade 9 essential. Again, this is not a blame game. It is not their fault that they don't have this content knowledge. Again, it's the way that they were taught. And so what we have to think about is how can we fix this? So there are many different ways to address math knowledge for teaching. And one thing we need to recognize is this actually takes some time. So it's not something that can be done right away. And quite often when we talk about enhancing math knowledge for teaching, we often think about, and I've been using examples of elementary teachers, but I also think that we have some similar issues at the secondary level, because quite often those who are teaching mathematics courses at the secondary level have taken university courses in mathematics. They have been very successful in mathematics being taught in a fairly procedural way. And so they're quite confident with the way that they teach mathematics, but may not be as comfortable in terms of opening it up to rich problem solving where students might approach it in a variety of different ways. So in some sense, sometimes they're a bit harder to convince that we need to open it up. In other words, if I do workshops with elementary teachers and we're working on mathematical ideas, they'll often walk away and say, wow, I wish I had learned math that way. Because quite often they were unsuccessful in being taught merely procedures. But that reaction is not the same when working with secondary teachers, because they did understand math in that way it was taught. What we need to do is to be able to help them recognize that not all students learn in that way. So different ways to address math knowledge for teaching is to provide experiences to enhance teachers' conceptual knowledge and procedural fluency in the areas that they're going to teach. So through some of the work that we do in terms of professional learning, to me, math has to be at the heart of all of it. To support teachers in their own teaching, either through collaborative work where they can go next door to somebody and find out, so here's a student solution, I'm not making sense of it, can you make sense of it? So to develop that comfort level where they can feel free to take risks, to say that they don't quite see what that student's doing. And there's also evidence that teachers can develop an understanding through their own teaching, depending on the kinds of things that they're doing. I recently was working on a research project with 4 grade 7 teachers who volunteered for me to come in and video record their classrooms, and then they got together and they together watched the video recordings of one another classroom. So obviously these people are fairly confident to be able to volunteer for this research project. And it was interesting because of the four, I think there were two of them who said that they were not confident in mathematics, but developed that confidence and investigated the mathematical ideas through their own teaching. So I find that quite interesting, and we see that quite often, as long as they're given the appropriate opportunities and they are in a situation where they can feel free to take some risks. Other work that could be done is offering courses. We've talked about that. Working with administrators to deepen their understanding of math knowledge for teaching. And so some work's been done across the province working with principals as instructional leaders to also enhance their understanding of mathematics so that they have more confidence working with teachers. Thinking about mathematics leaders and coaches. So often a literacy coach might be put in to be the coach for a mathematics class, which is great. They often know the structure and the appropriate classroom sort of strategies that should be occurring. But again, they might not know the mathematics to help that teacher develop their own math understanding. And for me, really, it's important to put math at the center of the professional learning that we're doing so that teachers engage in mathematical ideas. So, what are ways that we can support teachers in effective math teaching and learning? So I just want to go through, first of all, some key elements. And these key elements are actually drawn from research on professional learning, excuse me, for math and science teachers. So this is specific to math and science. So kind of four things. One is that it should be curriculum-based. And what that really means is not just the curriculum document, it means it should be math-focused. So in other words, there should be opportunities within that professional learning to dig deeper into the mathematics. Another is that it should be focused on student thinking, so that we're looking at the student thinking within that professional learning. And by looking at the student thinking, that also helps us with the mathematics. Sometimes I find I'll show videos of student thinking with teachers, and it's a non-threatening way to engage them in mathematical ideas and in other ways of thinking about how to solve problems in different ways. Another is that it should be collaborative, and it should be within supportive school and district environments. And collaboration is key. And that doesn't mean mandated collaboration. So in other words, okay, we've got to all work together because I read somewhere that this is the best way to do it. It is about teachers working collaboratively on things that they want to work on. So often when I set up a professional learning community, I ask the teachers as individuals, what aspect of their teaching do they want to work on? So perhaps it's student questioning, perhaps it's the use of rich tasks, and I find that having each person work on one key area, really, that's enough. If they're given too many things to work on at one time, then it's just not going to happen. There's too much going on. And one could still have a professional learning community where they're all working on enhancing math instruction, but they might be picking up different aspects of that. And in that way, too, they're sharing their learning in their particular aspects. So it's sort of differentiated learning for that PLC. Another is that it has to align with all the other elements in the system. And I find that we're fairly privileged in Ontario because I think all of our elements do actually align. So whether a teacher's reading a curriculum document or reading the growing success document or going to a professional learning session given by somebody who does those kinds of things, or picks up a practitioner journal around mathematics teaching, I think that they're getting the same messages because the kinds of things that we're doing in Ontario are fairly well aligned with current perspectives in math education and current research in math education, as well as assessment. And so I don't think we know how lucky we are because I go to other places where that actually is not true, and there's a lot of tension in terms of that. But I feel as though we are fairly lucky. So I'm just going to draw on a couple of aspects of that and then get some ideas from you about the kinds of things you've done, and then move into some models that I know sort of encapsulate some of those things we've just talked about. So this idea about being curriculum-based, that it really is an effective way for teachers to increase their mathematical and pedagogical knowledge. because that really is what we're looking at, not just pedagogical knowledge, but also mathematical knowledge. And they really need to be engaged in doing math together. It also focusing on the curriculum, and here I'm really talking about that which is displayed in the document. It helps teachers think about the continuum of mathematical thinking. So if I have teachers together by panel, so the primary teachers or the junior teachers, or maybe I have grade 7, 8, 9, 10, then they really are looking at, so how does that, let's say grade 7, 8, 9, 10, how does the concept of integers and operations with integers grow from grade 7 and 8 to 9? Or maybe I'm looking at grade 9, 10, 11, and 12. And what does the concept of function do as it progresses over time? So that we're able to think about particular concepts and how they grow. I think that's really important because sometimes teachers feel as though, oh my gosh, I have to cover all of this fraction stuff this year. Well, if you look back and you look ahead, you realize that you're not covering it all. Some they did before and some they're going to do. And so you get that sense as to where you are within that continuum. And so you're able to position yourselves. And I found that working with teachers to look at that continuum really kind of takes the pressure off and helps them focus on to what's the important part that I'm actually working on in this particular grade. This idea of collaboration is huge. We know that collaboration for professional learning, that could be networks within schools. It could be networks outside of schools and across school boundaries. And I think it's really important that sometimes you might get a brand new teacher in your school, and perhaps maybe some of the other teachers are much more traditional, and this teacher's coming in with some collaborative ideas. We have to be real careful that they don't sort of get absorbed in the other culture. And so you might want to be connecting some of those teachers with teachers in other schools through some professional learning opportunities at the school board level. So really to think about ways to help to create networks so that the teachers have some others to talk to who can push their thinking, but also who are like-minded in some ways. We know that there's been a lot of research around things like learning in rich schools as opposed to learning in impoverished schools. And thinking about those learning in rich schools as schools where the teachers interact frequently and they work closely together around issues of teaching and learning. And lots of research to support that so that we get a critical mass of people involved in working on changing instruction. We also know not everybody will be on board, but I find that it starts to snowball when a few people start to work on it. Sometimes people pick up the odd activity or idea and then eventually come on board. Another key piece is including you. So we know that the teacher is the #1 factor in terms of enhancing student achievement, and the school leader is the second most important factor. That really leadership for teaching and learning has a direct impact on student learning. That is widely recognized in any of the research literature on effective leadership. And then we have that knowledgeable other. So sometimes when we think about a professional learning community and we think about teachers get together and talk about teaching and learning, sometimes they need another voice in there. And because otherwise sometimes the conversation moves to sort of just the technical aspects of teaching as opposed to focusing on mathematical ideas or the students' mathematical thinking. And that knowledgeable other can come in a variety of different ways. It could be the math coach, it could be a school board math lead. It could also come from something that they're reading, so some reading material that might have a researcher voice in it, or a video that they're watching and reacting to. So the knowledgeable other doesn't always have to be an actual person in the room. One could structure their work around a knowledgeable other that comes in a different format. So I'm going to ask you to take a minute and share some professional learning community activities in math that have occurred in your context. Or you might not think about them as PLC activities. They might be just professional learning activities. So we'll give you a couple of minutes, 2 or 3 minutes, to share some of the things that you've been doing. So people can keep on typing if they have some other things to add. We're seeing lots of things. So a lot of co-planning, co-teaching, co-creating rich tasks, which is terrific. Talking about the three-part lesson. So I'll encourage, as we talk about the three-part lesson with our colleagues, that we make sure we include the math in there. I found for a while, I don't think this is happening now, but for a while there were a lot of professional learning around the three-part lesson or the math talk learning community that dealt with the structure of what was happening, as opposed to necessarily the math that was happening within that structure. So again, encouraging that we work in the math in some of that, which I imagine, many of you have been doing. And I see a lot of participation in things like CILM and working on some of that research and work with some of the trajectories, learning trajectories around some of that. I also like this idea of gathering the schools together so that you can work on similar grade levels in terms of things. Observing one another's classrooms with a focus, I would assume, on what the student understanding is. And look at this SCDSB with all those inquiries going on there. So lots of things going on, and it looks like you're all taking part in lots of really good professional learning, as well as setting the stage for your teachers in terms of professional learning. So I think I'll share with you sort of, it's almost a summary of some of the ideas that that you talked about. I see Barb also mentioned that sometimes it's hard to get math teachers on board with the change, particularly at the secondary level. And yeah, I've mentioned that. Sometimes the work I do with secondary teachers, sometimes what I do is I go back to the curriculum and I do an activity where we actually do that, pulling out the verbs. Because sometimes I hear from secondary teachers, I don't have time for investigations or kids to explain or demonstrate because I'm too busy with the curriculum. But if I actually look at the curriculum, that is the curriculum. And so it takes a while. The other thing is quite often at the secondary level, teachers feel they're preparing them for university. But I find quite often it's the university that they went to, not the one that actually exists today, much as grade 8 teachers might be preparing students for the grade 9 that they were once to. Some of the work that I do, or my connections with some math professors at a variety of universities in Ontario, they're doing collaborative problem solving. Some of them are using portfolios in a first-year calculus class. Not everybody, but we see it happening. Just like I told you, I saw the other night the professor asking for students to use an exit card before they left. So I think maybe more sharing about that. Maybe that's something that I could be doing more of, about the kinds of things that are actually happening at universities. And that this really, the best way to prepare students, I think, for wherever they're going is to deepen their mathematics understanding. So thank you all. Lots of great things happening. So let me just move on to the next slide, and I'll just highlight things that I think you're already doing, but maybe it'll reinforce that these are good things to be doing. So working together to examine student work. That could be video work, it could be written work, but I noticed some of you talked about designing tasks and going into classrooms, trying them out and bringing back the student work. Because that really helps us focus on student thinking, which we know is an important component that I highlighted in those 4 components. It also focuses on the math. So we're looking at what is the math. Hopefully teachers are trying the task first to anticipate what the students might be doing and then looking at what they do. And it's got that component of being collaborative. Another is a book study. So a book study also could be a small book. So it could be even a monograph or something like that. But what a book study does is it pulls in that knowledgeable other as well. And it helps people focus. Generally, a good book too might have some suggested tasks. It connects to classroom practice. And it gives teachers the opportunity to try out those tasks, bring them into their classroom, bring back the student work. The book might even include student work and have a discussion about that student work. And so in that way, teachers see value in the fact that this book connects to pedagogy, the mathematics, and as well as just their classroom practice. So some of the components of a book study would be it focuses on student thinking. Again, I'll give you a couple of books that I might suggest. It includes that knowledgeable other. Generally, a good book might be research-based. It's curriculum-based because it would have a focus on the mathematics going on, and a book study group would provide a collaborative space. One book that I know that some of the work I've been doing with some PLCs around the province that seems to resonate well with teachers is this book, The 5 Practices for Orchestrating Productive Mathematics Discussions. And I know if I had the opportunity for you all to raise your hand or something or not, I could probably see that many of you are familiar with this book or have used this book in a professional learning community. Well, this doesn't negate the 3-part lesson, by the way. 3 parts here, 5 parts there. Sometimes teachers get a bit irritated because, not something else new. But this actually goes along with a 3-part lesson, but it gives maybe a bit more detail in terms of what might those 3 parts look like. So it talks about anticipating. So taking a task and trying out that task, and perhaps in a group, and anticipating what might the student responses be? What might be some of their misconceptions? Or, like in that tug-of-war problem, what might be some of the mathematical approaches that they would take to this? So that would occur before the lesson. Then, as the lesson occurs and the students are working on a mathematical task, it's about monitoring. And that means paying attention to the mathematical thinking that's coming out of the students in this task, asking the right questions, posing appropriate questions, and responding in appropriate ways to the student thinking. It also then is about selecting and sequencing. So as one is monitoring, it's not as though every student needs to present the solution. Maybe the students are working in pairs or working in groups of 3 or 4. It really is thinking about, as you monitor, what solutions might make sense to be shared. And this doesn't necessarily mean it's the best solutions, and it doesn't necessarily mean it's a hierarchy of solutions. It's what solutions might help the students make connections. So in other words, if I think about that tug-of-war problem, it might be connecting 2 solutions that both use proportional reasoning, but one used a friendly number of 20 and one used a friendly number of 100, or thought about it as percents. But yet, the thinking behind it was very similar. So in that sense, the teacher is selecting and sequencing those 2 with the view that she or he is going to help to connect those mathematical ideas later. Or perhaps you're selecting and sequencing because you want a variety of different approaches to be displayed so that every student who tried an approach can perhaps connect what they did with one of those that's being displayed. So what I find helpful about this book is that, sometimes we talk to teachers about facilitating mathematical inquiry, and yet we can't really prescribe what that looks like because it depends on the student's thinking. And where we go next depends on the question I ask and the way the student responds. So it's very hard to give a prescription. It's sort of not like old school secondary teaching where I take up the homework, I give some examples, and then they do some more homework. That we could say, and that's what I call the old-fashioned 3-part lesson, that we could probably prescribe. This is more about paying attention to students' thinking, and it's hard for teachers to see what might this look like in a classroom. So I actually find that this book helps because it gives a bit more of a structure as to, so what is happening in those 3 parts of that lesson, and what does it look like? And it goes into great detail in terms of what that looks like. So that might be something that some of you might find useful. And I find that it could span a variety of grades. So I have found that secondary teachers have used this as well and have found it useful. Right now I'm working with 9 professional learning communities who are working on grade 9 applied mathematics. And many of them have taken this up within their PLC as a book study, and that was their choice. Another you could use, if a book is a bit too much to begin with, is to use some of the either the monographs or the paying attention series. So I guess we would call it a pamphlet study. So for instance, one that I've used quite often is paying attention to algebraic reasoning. And notice that it's K to 12. So it might be important for elementary teachers to know where that algebraic reasoning they're developing is going. And it also might be helpful for secondary teachers to know where their algebraic reasoning is coming from. I find quite often a grade 9 teacher might be using a term like table of values and not recognize that the kids have actually already done this before, but they might have been calling it a T-chart. So I've used that algebraic reasoning book sometimes as a bit of a jigsaw method so that different groups read different pages and then they get together and share their ideas using a jigsaw method. Or you could use one of the monographs. There are only 4 pages, and I happen to put up the one that I wrote only because I'll mention that it had that tug of war problem in it. So in other words, in that sense, we've got a mathematical problem that they could take to their class. They could try out solutions. They can bring it back. And a lot of what this monograph talks about is teacher questioning, so the kinds of questions that could be asked. So there are a variety of things that one could use as a book study to help to bring in that knowledgeable other. And a good source would be one that connects to teachers' classroom practice, gives them something that they can use in their class, and helps them focus on student thinking. So another PLC that many of you mentioned you've been doing is about a lesson study, or some of you mentioned that you were doing co-planning, co-teaching. So what does that really look like? It's really working with the curriculum, and I encourage people to also work with research and resources. So to me, a lesson study should not just be looking at the curriculum and using our own experiences. I think it's an opportunity to reach out. So let's look at, if we're dealing with primary students, let's look at a journal like Teaching Children Mathematics from NCTM and see whether there are any good ideas in there for a lesson. Or if I'm working in the junior or grade 7, 8, maybe look at the Teaching Mathematics in the middle school, another NCTM practitioner journal. Or if I'm at the high school level, then looking at a journal such as the Mathematics Teacher, again an NCTM journal. Or another good journal is the OAME Gazette, right here in Ontario, that has some great ideas for lessons and has a special part that's just for elementary teaching. So why not look at some other resources? What would be some other ways people might approach that? And then come together and think about, so what might this lesson look like? And then let's try this out in different classrooms with a focus not so much on what the teacher's doing, or not necessarily all the focus on the teacher and the act of teaching, but focus on the student understanding. So what are the kinds of things the students are understanding? Where are some gaps maybe where we need to collectively adjust this lesson to enhance that student understanding? And so that's pretty much what you're doing as you're co-planning and co-teaching, I believe. So some components of that then that we know are important: it has the student thinking, it focuses on the curriculum, it's a focus on pedagogy, and it has that alignment piece, particularly if you're working across grades. So you're really thinking about, so what's different about the curriculum in grade 4 and 5 and 6 with respect to fractions? How might this lesson be different for grade 4s, grade 5s, and grade 6s? And of course, it's collaborative, so it has that component as well. So 3 particular models, but I saw that many of you were using some of those models. Maybe this has been able to give you a couple of other ideas. I find that often you get other ideas by listening to what other schools are doing too. So that's why I think it's really important to have that sharing piece. So a few things that I'd like to emphasize in summary, and then we might have some time for some questions, is that learning takes time. I think that we need to think about teacher learning in much the way that we think about student learning. So what are the kinds of things that we would like in a classroom where mathematical work is occurring? Well, we want a safe environment for students to take risk. We want to be able to allow them space for productive struggle. We want them to have tasks and take on things that are appropriate to the kinds of understandings they have. We want them to connect to their prior knowledge. We want them to have opportunities to share ideas and collaborate. And all of those kinds of things are the kinds of things that also hold true for teacher learning. that they need a safe space to take risks, that we need to recognize that they have differences and that they're all in different places. And that if each one of those teachers who are part of that professional learning community moves their thinking forward, they're not all going to arrive at the same place at the same time. But if there's one particular aspect of their teaching that they'd like to work on and they move that forward, then I think that we can think about that as a measure of success. So, um, you know, in a way, we get a bit frustrated because not everybody seems on board, not everybody's moving their thinking forward, not everybody's paying attention to the research. But I find that most teachers are interested in enhancing their own teaching practice. And I find quite often if they get to choose which piece of their teaching they'd like to enhance or work on, that helps to get them on board in terms of moving forward. So for me, above all else, math has to be at the heart of professional learning. To me, we need to be engaged in doing mathematics when we come together in a professional learning setting. I think that that's one of the ways that we can help to deal with enhancing this math knowledge for teaching that helps teachers to then facilitate mathematics learning for their students. To me, that's one of the core pieces, and that's whether I'm working at an elementary school level or a secondary school level. Engaging teachers in mathematics that sometimes might, challenge their thinking, but helps them hopefully come away even with a new mathematical idea. And then it also helps them be convinced that thinking about math in these ways is really helpful. So I have some suggested readings and I'll take some questions. And I see that in the conference chat, there have been a few questions. Um, so Um, so Natalie spoke about, so let me just kind of review what some of those are because I was busy doing other things. So primary juniors who need no qualifications. Yes. Now, now that the teacher ed program is 2 years, I know that hopefully teachers, beginning teachers, prospective teachers, have a little more time to grow with some of those mathematical ideas. So I'm hoping that they might have a bit more confidence. And some of the faculties of education have actually included another course in the teacher ed program. For instance, we have one at the University of Ottawa called Enhancing Mathematics and Science Understanding. And it's a course that's just about deepening their own understanding, not about how to teach math and science, but it is about looking at some fundamental ideas in math and science and using an inquiry approach. And I know that other universities are doing that. And Gianna said secondary teachers are teaching in significantly different ways than students were taught in elementary. Yes, and we really need to think about having those. I like to think about grade 7, 8, 9, 10 teachers working together so that they can get to know one another's context and get to see some of the ways that they are taught. I also see some terrific things happening in secondary schools with conversations happening all the time. This whole whiteboard thing up on the walls, the vertical non-permanent surfaces, seems to have taken hold in many schools where teachers are making, in secondary schools, are making student thinking a bit more visible. So lots of work to be done still. So I have some suggested readings here, which might be useful for some of those book studies. So I've put some of those there so that you've got some of those. And I'll give you an opportunity for other questions and comments before we call it a day. So this is your chance.
Chris, I'm just going to step in here while we're waiting for some questions to be entered. If you did want to download a copy of today's presentation in PDF form, you'll notice that there's a files pod on the right-hand side of your screen. You would click on that file. You'll see a download files button highlight. Click on that. It'll take you to a different tab where you can retrieve the file. If you close that tab that opens up, it'll bring you right back into the platform here.
So again, a chance for some questions or comments. Also, my email address is on that last slide. So if you do have other questions that you might feel are maybe more individual questions or particular to your context, you can always email me.
So in order to download the presentation, you would click on the Adobe Connect March 2016.pdf in the Files pod, and then you'll see the Download Files pod button highlight. Click on that, it'll take you to a different tab, and you'll be able to access the file. So it seems we do have a few people who might be asking a couple questions. Also, I'd like to point out that we do have a pod there uh, just for some feedback. It's always, as we all know, feedback is important. It'll help us improve and produce a better product for you in the future. And hopefully, you can provide us about what you found useful about this webinar. That'll be in the bottom left-hand side of your screen. Thanks.
So Jennifer is asking about this is a dilemma, and there's no clear research to indicate which one is better, this math specialist teacher or homeroom teacher. There's actually something on the NCTM website. There's a sort of a research brief around this idea of math specialist teachers. So Jennifer, if you email me, I can send you the link to where that is. Um, of course, I guess that depends on that homeroom teacher, doesn't it? So, and it might depend on the grade level. So I know that different things are occurring in grade 7 and 8, where sometimes they're taught by a math specialist and other times that one teacher teaches all subjects. I guess our goal is to enhance the math learning of every teacher, and then we wouldn't really have that dilemma. And there's another question here. So Beth, that's a good question in terms of the French immersion. Um, there's no one working in Ontario that I know that's dealing with that right now, and there has been some research around French immersion in terms of sometimes the math lags behind, but then later gets caught up. Um, but that is a dilemma, particularly if they can't express their thinking in written form, and then certainly probably not orally as well. So that would be a really good thing to be looking at. Any other questions? I'm not answering your questions that well. I keep saying, no definitive research on these things. Okay. So I'm not seeing too many more questions. So what I'll encourage you to do is that, again, feedback is helpful. If there are any aspects of this webinar that you found useful, it's always good to know what that might be. It's really hard to do a webinar because you can't see people's faces and expressions and kind of know what they're connecting with. So it's helpful. And once you've done that, you might be working as a group and might want to continue your discussion. or whatever. But I'll just suggest that you have a good day, have a good weekend, and have a really good March break. Take care, everybody. And thanks so much for your contributions today. It really is helpful when you do a webinar for people to kind of key in ideas. It's much easier as a presenter to be able to connect with the kinds of things that you're doing. And so many of you are doing such wonderful things that great things are happening in this province. So thanks very much, and take care. Have a good day.